Okay, let's go back to our grid. We've previously found the vectors BH, so B to H, which we found was M plus K. We also found the vector A to T, which was 3M plus 3K. I'm also going to find one more vector which is going in the same direction, which is C to R. So the vector C to R, which is 1, 2 of the vector M, and 1, 2 of the vector K. So this one is 2M plus 2K. Now what you hopefully realize about these three lines that I've drawn, the green, the orange and the pink, these three vectors are all parallel. Now how can we tell that from the expressions of their vectors? Well, M plus K, that's written as simply as we can at the moment. But what I want to do with A to T is I want to factorize out the number 3. And what we get is M plus K in brackets. What that means is this is just 3 times the vector B to H, because B to H is M plus K, so A to T is just 3 times the vector B to H. Now if it's 3 times vector B to H, that means it's going in exactly the same direction, but it's just 3 times as big, 3 times as long. Okay? But it still means it's going in the same direction. And if 2 lines are going in the same direction, they have to be parallel. C to R, if we factorize that, take the 2 out, and that is also M plus K. It's also going in the same direction as B to H and as A to T. But this time C to R is just twice as big as B to H. So if you want to show that 2 vectors are parallel, you have to show that they have the same vector, but one of them is just some number bigger than the other one. Let's have a look at the kind of thing I mean. So if we want to match up parallel vectors here, we're going to have to factorize the expressions and see which vectors have got equivalent directions. So if I just do this in blue, A plus 3B, I can't simplify that as any more, and I can't factorize it. That's as simple as it will go. 3A minus 3B, well, that's the same as 3A minus B. 2A minus B, again, that's simplified as far as it will go. A plus B is simplified as far as it will go. 2A plus 6B, if I take a 2 out of the brackets, then that leaves me with A plus 3B. 6A minus 3B, I can take a 3 out of the brackets, and that leaves me with 2A minus 1B. 2A minus B. And A minus B, that's as simple as it will go as well. So, what you should be able to see is that the vector A plus 3B also appears here, which means that those 2 vectors which I've circled in red are parallel because they have the same vector, just one of them is twice as big as the other one. But it doesn't matter how many times bigger a vector is, if it's going in the same direction, they are parallel. A minus B is parallel to 3A minus B because you can see the A minus B is there. Those 2 vectors are parallel, and this one is 3 times bigger than this one. 2A minus B is parallel to 3 times 2A minus B. Same vector. This one is 3 times bigger. A plus B is the odd one out. It's not parallel to any of the vectors there because it hasn't got we haven't got another vector which has got an A plus B in it. Okay, let's have a look at an exam question. So this looks like quite a complicated shape, and it looks like we've given quite a lot of information, but a lot of information is good in vectors questions, because if we have a lot of information, that means there's less information that we need to work out. So a nice complicated diagram is our friend in vectors questions. Okay, so let's have a look and see what we've got. A, B, C, D, E, F is a regular hexagon. Okay, so A, B, C, D, E, F. There's a hexagon. And the vector A to B is little vector A. The vector B to C is vector B. And it also says that A to D is 2B. So A to D is 2B. Okay, and it says find the vector A to C in terms of A and B. So again, that just means we need to write down a vector with A and B in it. Alright, so what vector are we trying to find? We're trying to find the vector from A to C. Now, we don't know what that vector is already, so we have to find another route. Well, it's quite clear to see that if we go from A to B and then from B to C, we've made the same journey. So, the vector A to C is equal to the vector A to B plus the vector B to C. A to B is A, which we could also see from up here, and B to C is B. So the vector A to C is A plus B. Easy. Okay, now we're given an extra bit of information that the A to C is equal to C to X. So A to C is equal to C to X, and that's what these little lines mean. Okay, they're denoting equivalent lengths. Right, so if A to C is A plus B, like we've just worked out it is, then C to X is also A plus B, because if they're equal, then they have the same vector. Now what we need to do is prove that AB is parallel to DX. Now the first thing we need to do is make sure we know what both of these vectors are. Now we know what AB is, because we're given it in the question. We know that AB is the vector A. So to prove that DX is parallel to it, we need to prove that we could just multiply A by something to give us another vector. So these two vectors, this vector and this vector were parallel because they had the same vector, but we just times this one by a number, and so it was just 3 times bigger. So if dx is 2a or 3a or 4a or 5a or any other number times a, then it's going to be parallel to AB. But we need to obviously find out what dx is first. So let's have a look on our diagram at where dx is. So d to x is there. Okay. I don't know what the vector of this line is. It might look like it's equal to this line, but if this line had another little line through it, we can't assume that. So we can't go directly from D to X, so we're going to have to go around it. So we're going to go from D to A, then we're going to go from A all the way to X. So D to A, and then from A all the way to X. Okay, so I'm going to draw it over here to give myself enough space. So I want to find out D to X, and I'm going to go from D to A plus A to X, or I could think of it as A to C and then C to X. So A to C and then C to X. Now D to A is just minus 2b. Minus because it's going in the opposite direction of the arrow. Okay, hopefully you can see that that vector there is still 2b. Okay, so D to A is minus 2b. A to C is what we worked out in part A, which is A plus B. So A plus B. And C to X, we were told that C to X is equal to A to C. So that's also A plus B. Okay, let's collect all the like terms together. We've got 2 A's, and we've got minus 2b plus b plus another b. So we've got minus 2b plus 2 b's, which is going to mean that the b's cancel out and leave us with no b's at all in our answer. So our answer, dx, is just 2a. And because ab is a, that means that dx is 2 times ab. And so we've proven that they're parallel. Okay, we've proven that they're parallel because dx is just 2 times ab. So obviously it's going in the same direction as a to b. Okay, now you should be in a position to attempt question 2 of task A on your homework. So pause the video and have a go at that. Rewind the video if you need to go over the explanation again.